Let's go over Chapter 4 Practice Worksheet Part 2. First of all, we have to rewrite the following electron configuration using noble gas shorthand. So let's take a look at the first one. What we see is that we have a total of 7 electrons. If we have 7 electrons, the atomic number for our neutral atom is 7. Therefore, we're looking at nitrogen. For your periodic table, noble gas shorthand configuration, the noble gas on the line before is helium, and here are your inner electrons for the configuration of helium. And then you will copy what you have left, 2s2, 2p3. Those are your outer electrons. For B, we can do the same thing. So we have a total of, if you add all of these electrons together, we have here a total of 55 electrons. Atomic number 55. We're looking at cesium. The noble gas that comes before is xenon. Here are your inner electrons for xenon. And then we have the outer electron 6s1. For the last one, so we can do the same thing. We're going to count our electrons 2, 2, 6, 2, 6, 2, 10, and 3 for a total of 33 electron, Z equal 33. Therefore, here we are looking at arsenic. And the noble gas in the period before arsenic is argon with 18 electrons. So we have here 18 inner electrons, and we're going to copy, we have the 4s2, the 3d10, and the 4p3 that are our outer electrons. Problem 2. Write the configuration for iron using the noble gas shorthand. So remember that the symbol for iron is Fe. The atomic number for iron is 26. If you look at your periodic table, the noble gas that comes before is argon. And then going through the periodic table, 4s2, 3d6. So we have here with argon the 18 inner electrons. Those electrons here are called the outer electrons, and I have 6 plus 2, 8 of them. If I add together the inner electrons and the outer electrons, I get 26 electrons total, which is the number of electrons that I have in a neutral iron atom. And then we have here the valence shell containing 2 valence electrons. These valence electrons are parts of the outer electrons. Remember that the valence electrons can only be found in the S and P sublevel of the higher energy. Problem 3. Write the electron configuration for each using the noble gas shorthand. So we can first do selenium, atomic number of 34, neutral, so we have to place 34 electrons. Noble gas shorthand will be argon, 4s2, 3d10, 4p4. The second configuration we have to write is strontium with an atomic number of 38. Noble gas shorthand, krypton, 5s2. Then here, what do we have to do? We need to take a look at B, which is the selenide ion that carries a net charge -2. In order to get a net charge of 2 negative, what do we need to do? We need to gain 2 electrons. These electrons will go on the outermost shell, and the new configuration becomes argon, 4s2, 3d10, 4p, 4 plus 2, give me a 4p6. Argon 4s2, 3d10, 4p6, it's actually the configuration of the noble gas krypton with 36 electrons total. If I look at D now, Sr2+, this is the strontium ion. This ion carries a net charge of +2. How do I get a net charge of 2+? By losing 2 electrons. Therefore, I need here to take away 2 electrons. My new configuration, therefore, is only Kr bracket because the 5s is empty. What is this configuration? Well, this is the same as the configuration of krypton with 36 electron total. Therefore, the selenide ion and the strontium ion have the same number of electrons and both have the noble gas shorthand, the electron configuration of krypton. These two ions are said to be isoelectronic with krypton. Isoelectronic means that they have the same number of electrons means that they have the same electron configuration. Now let's answer a couple questions on the electron configuration and the periodic table. Which of these is a p block element? Well, only boron belongs to the p block, therefore this is the correct answer. Calcium belongs to the s block. And the other element do not belong to the p block. Gold belongs to the transition metal block, the D block, and P, if I can find it on the periodic table for you. Oh, it belongs to the F block. It's an actinide. Okay, so here, F block, this one, gold to the D block, and calcium belong to the S block. So only B, boron, belong to the P block. Which of these has 6 valence electrons? To have 6 valence electrons, you need to belong to the group 6A, or you need to have gained or lost electrons and to be an ion in order to have less electrons or more. Bromine belongs to group 7A, so bromine has 7 valence electrons. Oxygen belongs to the group 6A, so has 6 valence electron. The oxide ion carry a net charge of 2-, so has 6 + 2, 8 valence electrons. And neon belong to the noble gas group, mean that they have 8 valence electrons as well. So the correct answer is oxygen. Which atom has an electron configuration that is neon, 3s2, 3p3? So if we add up all the electrons, we have 10 for neon, +2 + 3, so total of 15 electron. Atomic number 15, the element that has the atomic number 15 is phosphorus, P. Which of these has an electron configuration of bracket helium? So what is bracket helium? Bracket helium has 2 electrons. It's the 1s2 with 2 electrons. So let's take a look. Fluorine has 9 electron total because the atomic number of fluorine is 9. F- carries a net charge of -1, so we'll have 9 + 1 = 10 electron. Lithium carries a positive charge, so we'll have 3 - 1 = 2 electrons. This is the correct answer. The lithium ion is isoelectronic with helium. Sodium, to be sure that this is not the correct answer, will have 11 - 1, 10 electrons. Which of these has 8 valence electron? So the option to have 8 valence electrons is to belong to the group 8A, the noble gas. Be careful, helium is an exception, only has 2 electrons. Okay? 2 valence electrons. Okay? So not the correct answer. Now I'm going to look at Br, O, and the bromide ion, Br minus. Well, Br belongs to group 7A, so 7 valence electrons, not the correct answer. Oxygen 6A, 6 valence electrons, not the correct answer. So why is bromide the correct answer? Because the bromide ion has 7 valence electrons when it's neutral, plus 1 to get the net charge -1, so add as 8 valence electron total. Which of the 2 sublevels form an atom's valence? It's only the S and the P sublevels. So be sure to remember that. The maximum number of electrons in S is 2. The maximum number of electrons in the P sublevel is 6. Therefore, the maximum number of valence electrons is 8. How many valence electrons do neutral alkali metal have? Well, alkali metal, this is the group 1A, therefore they will have 1 valence electron. How many valence electrons do the halogens have? Well, the halogens belong to the group 7A, therefore 7 valence electrons. What subshell is filled after the 3D? After the 3D comes the 4P, it's actually the 4S, then the 3D, then the 4P. What is the electron configuration of the highest field sublevel for nickel? Nickel has an atomic number of 28. Nickel is located in the D block. In the 8th column of the D block, so 3D8 will be the highest field sublevel. Identify the group of elements with this characteristic. A. This group of elements has a valence electron configuration of S2P5. So, S2P5, meaning that we have a total of 2 plus 5, 7 valence electrons. This is the group 7A, and this group is called the halogens. This group of elements has a completely filled valence. What means completely filled valence? It means S2P6 with 8 valence electrons. This is the group 8A, the noble gases. This group of elements has 2 valence electrons, so we're looking at S2. 2 valence electrons mean this is the group 2A, and the group 2A is the alkaline earth metals. This group tend to lose 1 electron. So the group we're looking at tend to lose 1 electron, minus 1 electron, to look like a noble gas. So in order to look like the noble gas, they need to lose 1 electron. Therefore, they only have 1 valence electron. In order to have 1 valence electrons, they belong to the group 1A, and this group is the alkali metals. Thank you. And if you have any question, feel free to contact me.